All right, open up your book to section 4-7. We're on page 227 in your book. The title of this section is Fractional Equations and Extraneous Solutions. And the objective here is given a rational algebraic function f, find x for a given value of f of x. So we're going to look to be able to solve rational equations. All right, there's several examples that I want to go through here with you. So look at example number 1. Example number 1 says for the function f of x equals that rational function there, find out x algebraically if f of x is equal to 6. So we've got f of x is equal to x squared minus 5x plus 10. And we're dividing that by x minus 3. And we're trying to find out where this is equal to 6 is what we're trying to do here. Now the first thing I want to indicate here is what our domain is. And the domain is going to be determined based on what I see in the denominator here. We need to be able to factor that to find out where the zeros are at. So x cannot be equal to 3 is our domain. So as we go through this problem, just keep in mind that x cannot be equal to 3. The first step to solving this is we're going to multiply both sides of this equation here by x minus 3, by that denominator, to get rid of the fraction. So you'll end up with, on the left side, x squared minus 5x plus 10, and that's equal to 6 times x minus 3. You'll notice at this point that this expression, or this equation, is now defined at x equals 3. Which is why it's important that we indicated up above that x cannot be equal to 3, and we keep that in mind as we're solving this problem, that our domain does not include x equals 3. All right, let's multiply the right side out here. So you'll have 6x minus 18. This is just a quadratic equation, actually, so let's just move the 6x and the 18 over to the other side. So subtract those. You'll have x squared. When I subtract 6x, it'll be a minus 11x. When I add 18, it'll be a plus 28, it looks like over here, and that's equal to 0. So a quadratic equation, we've now solved these a number of times here. Look, if we can factor this, then let's factor it. Otherwise, let's use quadratic formula. But it looks like this factors, right? Two numbers whose product is 28 and sum is 11, or negative 11, sounds like a negative 4 and a negative 7. So x minus 4 and x minus 7 sounds like our two factors. And again, once I have these two factors set equal to 0, I just set each of those equal to 0 and solve. So x is equal to 4 and 7. And again, think about your domain that we started off with. X could not equal 3, and that's not one of our solutions that we came up with. So those are our two solutions to this equation here, 4 and 7. All right, let's take a look at the next example there on the next page, example number 2. They give us, actually, this is the same function here. This is f of x is equal to x squared minus 5x plus 10 divided by the x minus 3. And they want us to set this equal to 4 this time. Again, you should start out by considering the domain of each one of these. So it's going to be the same domain here based on this guy right here, that x cannot be equal to 3. All right. We'll go through the same process here. Let's just multiply both sides by x minus 3 to get rid of the fraction. So you have x squared minus 5x plus 10 is equal to 4 times x minus 3. And again, at this point right here, this equation is defined at x equals 3. Which is the reason why we had to find the domain to begin with, so we remember that x cannot be equal to 3, even though this new equation is. All right, let's do the same process here. Let's handle the right side of this first and multiply the 4 through there. We got 4x minus 12 when we do that. And now this is quadratic, so let's just get everything over here on the left side. So let's subtract the 4x and add the 12. We've got x squared, a negative 5 minus 4x is going to give us a negative 9x. And then 10 plus the 12 will give us 22. And then, again, if that factors nicely, two numbers whose 22, product is 22 and sum is -9. Well, that's close, but 11 and 2 sound promising, but unfortunately I'm not going to get the right signs that go with that. So you might have to run this through your quadratic formula then. X would be equal to the opposite of a -9, that's 9 plus or minus the square root of b squared, that's a -9 squared is 81, minus 4ac, 4 times 22 is 88. Oh, there we go, there's a problem. We're taking the square root of a negative number there, all over 2a. So this has no solution. Okay, it turns out that this rational expression there, this rational function, is never equal to a value of 4. And actually, we can grab our calculator and see why that's the case. Go ahead and grab your calculator and let's try this out here on our calculator. All right, so on your calculator, let's go to your y equals menu and let's put in the function f of x that they gave us, which was x squared minus 5x plus 10. And we'll divide that by x minus 3. And then let's actually go back to example 1 where we set this equal to 6. And let's graph y2 is equal to 6. And in y3, let's graph the value they had us set it to equal in this one, which was 4. And let's just graph this in the standard window there. All right, that graphed really fast there, but it looks like the red curve there is what we did in example 1. You'll notice that it looks like it crosses that blue curve there 2 places. That must be the 4 and the 7 that we came up with. You'll also notice that we have a vertical asymptote. It looks like right at 3. This is why we had to eliminate that from being part of our domain. We said x can't be equal to 3. But then you can see y equals 4. That's the black line that you see there. That doesn't cross our function at all. This is why there's no solution. It's never equal to that value. In fact, it looks like that if I picked any value between, probably -3 and +5, somewhere in there, that there would be no solution. All right, it might be actually a solution right at -3 or right at -5, but anywhere in between, doesn't look like we'd get a solution there. I'll just paste this in here so we can see why that was no solution. All right, let's look at one last example then. Example 3 there on page 229. This time we're going to find the intersection of two graphs. And the two graphs that they give us f of x f of x is equal to x over x minus 2 plus 2 over x plus 3. So that looks like somewhat two fractions there. It almost looks like that's had a partial fraction decomposition done to it. That's what it kind of looks like. But anyways, g of x is 10 over x squared plus x minus 6. In fact, that looks like that factors. I'm going to do that actually right now. Let's go ahead and factor this denominator. That will probably be helpful to us when we go to solve this. It looks like x, what do I need? I need a -2 and a +3 here, right? X plus 3 and x minus 2. Well, that turns out to be really nice. Those are the same two denominators that I see in f of x. So, all right. They want us to set these two equal to each other, so I've got x over x minus 2 plus 2 over x plus 3, and I'm setting that equal to, I'm going to write it in this second form, x plus 3 times x minus 2. And what I'm going to do is multiply by a value here to get rid of the fractions, which actually turns out to be pretty nice here. I can see that these fractions all involve an x plus 3 or an x minus 2. So if I multiply everything by x plus 3 times x minus 2, that's what I want to do. Multiply everything by the same thing and eliminate the fraction. So that's what we're going to do here. Notice what happens in this first fraction. The x minus 2 in the denominator will cancel with the x minus 2 that I'm multiplying by, and I'll be left with x times x plus 3. In the second fraction, when I multiply it by that quantity, the x plus 3's this time will cancel out, and I'll be left with 2 times x minus 2. And over here on the right, actually that entire denominator will cancel out with everything I'm multiplying by, and I'll be left with just my 10. All right, let's simplify this a little bit. On the left side here, we've got an x squared plus 3x. If I multiply that out, do the same for the second part. I've got 2x minus 4. I multiply the second part out, and that's still equal to 10. So this is just a quadratic equation again. Let's move everything to one side and simplify here. I've got x squared. I'll have 5x when I combine the 3x and the 2x. I've got a minus 4, and I'm going to subtract 10 more, so it's a minus 14. And that's equal to 0. And again, if you can factor this, then factor this. So one thing I did not do, that I better go back and do, is I didn't consider my domain here on this original equation. Oops, it was right here. Notice that I can't have x equal to 2 because of these two guys. So x cannot be equal to 2. And it can't be equal to a value of negative 3 because of these guys here. So x cannot be equal to a negative 3. Keep that domain as you go through here in mind, because on the next step there, that equation that I wrote down in the next step is not undefined at 2 and negative 3, but the original was. All right, so what does this simplify to? I need two numbers whose product is negative 14 and sum is 5. That sounds like a 7 and a 2, a positive 7 and a minus 2, right? X plus 7 times x minus 2 sounds like that would give us our solutions. And we end up with x is equal to a negative 7 or 2. And oh, there's our problem, right? X equals 2 was not part of our domain, so I got to get rid of that one. Don't erase it, but rather just simply cross it off so that we know that x equals negative 7 is actually our only solution here. We can do the same thing we did on the last problem just to check our work there. So grab your calculator and let's check to see what we came up with. All right, so on our calculator, let's get rid of these equations that we had a second ago and put in our new equations here. We've got x divided by x minus 2 and 2 divided by x plus 3. That was f of x, and then 10 divided by, I guess you could write it in factored form or write it in the original form. I'm going to go ahead and write it in the original form here, x squared plus x. Probably that's the safe thing to do each time. That way, in case you messed up in factoring it or whatever, you'll find that out here when you go to look at this graph. We'll graph this in the standard window here again, which is where we're at. And now you're looking for intersections here. So it definitely looks like you have an intersection over on the left there, somewhere in the negative domain there. I can see that the blue curve starts out on top and the red is on bottom, and then they flip-flop. It's hard to tell near that vertical asymptote over on the right, though. There's a vertical asymptote at x equals 2. Is there an intersection there or not? And this is the nice thing about the algebraic solution, is I find out that there isn't one over there. All right, I found that there's only one solution. But graphically, that would be difficult to find. I'm going to go ahead and grab a picture of this. Again, you can see that at x equals negative 7, if I look at that sketch, at x equals negative 7, that must be the solution that happens somewhere over here around negative 7. That definitely looks like a solution, but it's hard to tell. You know, is there a solution that happens up here, or is there a solution that's happening over here, or is there an intersection that I see there? Well, the algebra told us the answer to that question is no. There is no solution there. So, no to this, and no to that. Those are not solutions there. All right, that right there is the last section of this chapter, section 4-7.